All right, let's get into a really cool cosmic mystery. We're going to take a journey about 27,000 light-years from Earth to check out this glittering ball of stars that might be hiding a seriously dramatic secret. We're talking about the ghost of a galaxy that our own Milky Way ate billions of years ago.
So here's the big question, the one that this whole new study is trying to answer. Are we looking at just another star cluster? Or is this the dense, surviving core, the actual stolen heart of a galaxy that doesn't even exist anymore?
And there it is. This is Messier 19, or M19 for short. You can find it in the constellation Ophiuchus. Now, this is what we call a globular cluster, which is basically a dense swarm of hundreds of thousands of really, really old stars. And yeah, at first glance, it's just beautiful, right? But when scientists looked a little closer, they found something very, very strange.
To really get why M19 is such an oddball, you have to know that not all globular clusters are the same, not even close. M19 is a true cosmic anomaly, and all the clues are written right there, in the light coming from its stars.
You see, M19 is what astronomers call a Type II globular cluster. Now, what that means is, unlike most clusters, its stars have wildly different amounts of heavy elements, things like iron. That chemical complexity, that's a huge red flag. It suggests that M19 wasn't born here in the Milky Way. Instead, it was probably the central engine of a small dwarf galaxy that just got a little too close, got torn to shreds, and had its core captured by us.
And when you put them side by side, the difference is just wow. A normal Type I cluster, all its stars have pretty much the same chemical makeup. They're like siblings, born from the same cloud of gas. They're natives. But a Type II cluster, like M19, well, it's a total chemical melting pot. It's a galactic immigrant. And this new research set out to prove it. The question is, how?
Well, you can't exactly put a star on a scale, right? So to dig into M19's past, scientists needed a really clever way to weigh its stars from 27,000 light-years away. And the solution they used is this incredible technique that basically lets them listen to the stars themselves.
This technique is called astroseismology, and it's kind of like how earthquakes tell us about the inside of the Earth. Starquakes, these tiny stellar oscillations, tell us all about a star's internal structure. These vibrations actually cause the star's brightness to flicker in very specific patterns, almost like a stellar heartbeat.
So here's how it works. First, using data from telescopes like the K2 mission, scientists watch for these incredibly tiny changes in brightness. Then, they analyze those flickers to figure out the specific frequencies. You could even think of them as the notes the star is singing. And from those notes, they can precisely calculate all sorts of things. But most importantly for this case, the star's mass.
Okay, so armed with this amazing tool, the researchers went on a little clue hunt inside M19. And what they found was basically a case of missing mass, or I guess mass that was being lost at a truly shocking rate.
They zoomed in on the red giant stars. As stars kind of like our sun get older, they swell up into these huge red giants, and they start shedding a ton of their outer layers into space. And how much mass they lose is this super important factor that basically decides what happens to them next. The team suspected this mass loss could be the key to unlocking M19's secret.
And the results were, honestly, jaw-dropping. In a typical cluster, something like M9, the red giants lose, on average, about 0.16 times the mass of our sun. Okay? That's our baseline. But the red giants in M19, they're shedding 0.33 solar masses. That's more than double the amount. They are losing mass way, way more aggressively than stars in normal clusters.
Just think about that number for a second. 0.33. That is a third of our sun's entire mass being blown off into space by a single red giant in M19. This isn't some small statistical error. It's a massive difference that just screams for an explanation. This was the smoking gun.
So this extreme mass loss tells us that the stars in M19 are just fundamentally different. They're not just hanging out in a weird place. They are actually evolving by a different set of rules that were shaped by a completely different history.
See, in astrophysics, there's this known relationship, a kind of rule of thumb, called the mass loss metallicity trend. And basically, it says the more heavy elements, or metals, as astronomers call them, that a star has, the more efficiently it can push its outer layers away, and so the more mass it loses. It's a pretty predictable pattern that almost all star clusters follow.
So normally, star clusters follow this nice, predictable trend. You can see it right here with clusters like M9, M4, and M80. They're all right there on or near the line, just like they should be. But then, look at M19.
It is so far off the line, it's not even funny. It's a massive outlier. For its chemical makeup, it's losing way more mass than it has any right to. It's totally breaking the rules.
This table really just lays it all out. On one hand, you've got M9, a typical Type 1 cluster. Simple, uniform iron content, predictable mass loss. A Milky Way native. Then you've got M19, complex, huge variations in iron, way higher mass loss, and a suspected foreign origin. I mean, all the puzzle pieces are pointing in exactly the same direction.
So what's the big takeaway here? What does this all mean? Well, the story of M19 isn't just about one little cluster. It's really about uncovering the violent, cannibalistic history of our very own home galaxy, the Milky Way.
The bottom line is this, that extreme mass loss is the missing link. It's hard physical evidence showing that the stars in M19 have just lived a different life. Their unique evolution is powerful support for the theory that M19 isn't a native cluster at all, but is the dense surviving heart of a dwarf galaxy that we shredded and absorbed a long, long time ago.
And hey, don't just take my word for it. The study's authors put it perfectly. They said this isn't just a one-off fluke in M19. It suggests that all Type 2 clusters, all these suspected galactic cores, might share the same strange feature, like a scar left over from their unique and violent birth.
And this is why this is all so important. By finding and studying these immigrant clusters, we can start to piece together how the Milky Way was built, one devoured galaxy at a time. This method, astroseismology, is turning out to be a game changer for this kind of galactic archaeology. And with amazing upcoming observatories like the Roman Space Telescope, we're going to get a whole lot better at finding them.
Which just leaves us with this final, incredible thought. M19 was hiding in plain sight this whole time. It really makes you wonder, how many other galactic skeletons are out there, orbiting our galaxy right now, just waiting for us to finally uncover their stories?